Welcome to Kwiiz Success, India's trusted platform for IIT-JEE and NEET.
Introduction. Hey Neeta, have you ever wrapped a birthday gift?
Yes, many times.
That means you've covered the surface area of a polyhedron with wrapping paper. Have you ever poured yourself a glass of milk?
Yes.
That means you filled the volume of a glass with liquid.
I do not understand what you are saying. What is the surface area and the volume?
Surface area is exactly what it sounds like. The area of all the outside surfaces of a three-dimensional object. And volume is all of the space inside a three-dimensional object.
In this lesson, you will learn more about both of these concepts as well as how to compute the surface area and volume of combination of solids. Objectives. At the end of this lesson, you'll be able to find the surface area of an object formed by combining any two of the basic solids, namely cuboid, cone, cylinder, sphere, and hemisphere. Find the volume of objects formed by combining any two of the basic solids. Define the frustum of a right circular cone. Find the volume of a frustum of a cone. Find the curved surface area of a frustum of a cone. Find the total surface area of frustum of a cone. Combination of solids. Students, look at these solids. These solids are made up of two or more solids. Here we can clearly see that a circus tent is a combination of a cone and a cylinder. A spinning top is a combination of a hemisphere and a cone. And the test tube is a combination of a hemisphere and a cylinder. In the same way, in our daily life we observe many objects like toys, vehicles, vessels, tools, etc., which are combination of two or more solids. Let's learn to find their surface areas and volumes. Surface area of a combination of solids. To find the surface area of a solid made up of combination of solids, we break it into smaller solids and then find the curved surface area of each solid and add all areas to get the surface area of such a solid. For example, look at this toy. This toy is a combination of a cone and a hemisphere. To find the surface area of this toy, we will find the surface area of a cone and a hemisphere. Or we can say that the total surface area of a toy will be equal to the curved surface area of hemisphere plus curved surface area of the cone. Let's solve some examples to find the surface area of combination of solids. Example. A solid toy is in the form of a hemisphere surmounted by a right circular cone. If the height of the cone is 4 cm and the diameter of the base is 6 cm, calculate the surface area of the toy. Solution. We are given the height of the cone, which is equal to 4 cm, and the diameter of the base is 6 cm. As the diameter of the base is 6 cm, so the radius of the cone R is half of the diameter of the base, that is 3 cm. Also, radius of hemisphere is 3 cm. Now to find the surface area of the toy, we need to find the curved surface area of the cone and curved surface area of the hemisphere. The curved surface area of the cone is equal to pi RL. So, now we have to find the value of L, slant height. We know that slant height L is equal to square root h square plus r square, which equals square root 4 square plus 3 square is equal to square root 16 plus 9 is equal to square root 25 equals 5 cm. Now substituting the values of pi, r and L, we get 3.14 into 3 into 5, which is equal to 47.1 centimeter square. Let's now find the curved surface area of the hemisphere, which is equal to 2 pi r square. So we get 2 into 3.14 into 9 is equal to 56.52 centimeter square. Hence, the surface area of the toy is equal to curved surface area of the cone plus curved surface area of the hemisphere. This is equal to 47.1 plus 56.52. This gives 103.62 centimeters square. Example. Look at the figure. This decorative block is made of two solids, a cube and a hemisphere. The base of the block is a cube with edge 5 cm and the hemisphere fixed on the top has a diameter of 4.2 cm. Find the total surface area of the block. Solution. The total surface area of the cube is equal to 6 into edge square, which equals 6 into 5 into 5 centimeters square, which is equal to 150 centimeters square. We can see that the part of the cube where the hemisphere is attached is not included in the surface area. So, the surface area of the block is equal to total surface area of cube minus base area of hemisphere plus curved surface area of hemisphere. On substituting the values, we can find the surface area of the block, which is 163.86 centimeters square. Volume of a combination of solids. When we come across a combination of solids, the problem of finding the capacity arises. To find the volume of such a solid, we break that into smaller solids and then find the volume of each solid and add them up to get volume of such a solid. Look at this ice cream cone. It is a combination of a cone and a hemisphere. To find its volume, we will find out the volume of the cone and the hemisphere and add them. Or we can write it as volume of an ice cream cone is equal to volume of cone plus volume of hemisphere. Let's solve an example to understand more about this. Example. An iron pillar is a combination of a right circular cylinder and a right circular cone. The radius of the base of each of cone and cylinder is 8 cm. The cylindrical part is 240 cm high and the conical part is 36 cm high. Find the weight of the pillar if 1 cubic centimeter of iron weighs 3.9 grams. Solution. Let R is equal to radius of the cylinder, radius of the cone. H is equal to height of the cylinder. H1 is equal to height of the cone. We know that the total volume of the pillar is equal to the volume of cylinder plus volume of the cone. Therefore, total volume is equal to pi r square H plus 1 by 3 pi r square H1. This is equal to pi r square into H plus 1 by 3 H1. Solving this, we get total volume is equal to 50688 centimeter cube. Now total weight of the pillar is equal to volume of solid into weight per cubic centimeter. This is equal to 197683.2 grams or 197.6832 kilograms. Conversion of solid from one shape to another. When we cut a watermelon into slices, we are converting a solid shape into other solid shapes. Regardless of the size and shape of the slices, there is one fact that holds true of the whole process. The volume of all the slices together exactly equals the volume of the original watermelon. When we convert a solid of a given shape to a solid of another shape, the surface area usually changes. However, the volume is preserved. Similarly, in case of cutting bread into slices, we convert a solid shape into other solid shape. The volume of all the slices together exactly equals the volume of the original object. Example. A cone of height 24 cm and radius of base 6 cm is made up of modeling clay. A child reshapes it in the form of a sphere. Find the radius of the sphere. Solution. We know that volume of cone is 1 by 3 pi r square H, which is equal to 1 by 3 into pi into 6 into 6 into 24 centimeter cube. If r is the radius of the sphere, then its volume is 4 upon 3 pi r cube. Since the volume of clay in the form of cone and the sphere remains the same, we have That is, so r is equal to 3 into 2 is equal to 6. Therefore, the radius of the sphere is 6 centimeter. Assessment. Now answer the given questions. Click the correct option. Frustum of a cone. If a right circular cone is cut off by a plane parallel to its base, then the portion of the cone between the cutting plane and the base of the cone is called the frustum of the cone. The formulae for the frustum of the cone are given below. We will find the volume and the surface area of the frustum of the cone using these formulas in next screen. Example. The slant height of the frustum of a cone is 4 cm and the perimeters of circular ends are 18 cm and 6 cm. Find the curved surface area and the volume of the frustum. Solution. Let R1 and R2 be the radii of the base and top of the frustum. Then 2 pi R1 equals 18, which implies R1 is equal to 9 upon pi centimeter, and 2 pi R2 is equal to 6, which implies R2 is equal to 3 upon pi centimeter. Therefore, curved surface area of the frustum is equal to pi into R1 plus R2 into L, which equals pi into 4 into 9 upon pi plus 3 upon pi centimeter square, which equals 48 centimeters square. Now we find height of frustum by using the formula. L square is equal to h square plus R1 minus R2 square. H square equals L square minus R1 minus R2 square. By substituting the values we get h equals 3.51 centimeter. Volume of the frustum of the cone is, by substituting the values we get, volume of the frustum of the cone is equal to 43.50 centimeter cube. Assessment. Let us know how much you have learned. Click the correct option. Did you know? Frustum is a Latin word meaning piece cut off and its plural is frusta. Usually when we say cylinder, we mean a circular cylinder, but you can also have elliptical cylinders like this one. You can even have stranger cylinders. If the cross-section is curved and is the same from one end to the other, then it will still be a cylinder. Of all the shapes, a sphere has the smallest surface area for a volume. Or put another way, it can contain the greatest volume for a fixed surface area. Summary. Let us summarize what we have learned. To find the surface area of a solid made up of combination of solids, we break it into smaller solids and then find the curved surface area of each solid and add all areas to get the surface area of such a solid. To find the volume of a combination of solids, we break that into smaller solids and then find the volume of each solid and add them up. Given a right circular cone, which is sliced through by a plane parallel to its base, when the smaller conical portion is removed, the resulting solid is called frustum of a right circular cone. The formulae involving the frustum of a cone are: where h is equal to vertical height of the frustum, L is equal to slant height of the frustum, R1 and R2 are radii of the two bases, ends of the frustum.
Friends, welcome to Kwiiz Success. Now, there's no need to memorize without understanding. Our innovative learning technique helps you grasp concepts easily and effectively. Here, you'll find the perfect combination of 3D animated videos, AI-powered test series, and ebooks enriched with MCQs and mind maps. We offer the foundation course for class 8 to 10 students and the success blueprint course for class 11 and 12 students, providing a real exam experience and a boost in confidence. All our courses are designed by IIT and IIM alumni to ensure top quality learning. Whether it's an engineering entrance, medical entrance, or any competitive exam, success is now in your hands. Thousands of students have already benefited and now it's your turn. Study from home, at your own time, and at your own convenience. Visit www.success.org.in or scan the QR code to download the Kwiiz Success mobile app for free. Take mock tests, practice regularly, and see real improvement in your scores. Please subscribe our YouTube channel, Kwiiz Success. Also share it with your friends. Thank you.